right, welcome everyone. Today we're going to do nested iteration. Definitely one of the topics that you're going to deal with a lot here at the end of Mod 1, kind of like on all of the assessments that we are asking you to complete, and for the specifically on the independent challenges. So you can never have enough practice with this. So yeah, that's what we're gonna do today. Today is like less of like a lesson plan and more of like, let's do this thing and do it together. And so, excuse me, the way that this will go is like, you'll do a thing, I'll do a thing, we'll talk about that thing, and like rinse and repeat all the way through. So yeah, exciting. I like this lesson a lot. All right, so let's jump into it. So I'm going to drop a warm-up task in the channel. It's there, and then I can also just drop it in the Zoom chat so you have it both places. But yeah, so there's like 3 tasks to do. Let's take like 5 minutes on our own and do these, and then we'll come back together and we'll have you all, I'll drive, and we'll have one of you all navigate me. All right, let's have some volunteers guide me through implementing each of these. So I'll share my screen, uncomment this, and yeah, if you want to take me through and navigate me through what you came up with for any of these first 3 tasks, then I'm happy to do it. Cool, yeah, Luke, go ahead.
All right. I just figured out the second one, so I'm going to do the second one.
All
right. I did that, and then animals dot find under. Oh yeah, on line 15, animals dot find underscore all, and then squiggly bracket, and then in pipes put animal, end pipes, and then animal if animal dot length greater than equal to 4. And then that should do it.
Cool. So yeah, I will P this to the screen. Cool. So looks like that ran as I would expect. However, there is one thing I don't love about this implementation. Does anyone want to point out what it is if you think you know what it is?
If?
Yeah. Was that Leah?
Mm-hmm.
And what'd you say? Sorry.
The if, couldn't you just do animal.length?
Yeah, so what I don't like is this if statement here, so animal if, because I want find all to take a condition, just the condition, not the conditional like flow of the if statement. And I want it to evaluate this like Boolean condition here. And basically, if this evaluates to true, give me the element. If it evaluates to false, then skip that element and move on to the next one. Luke, I saw you put your hand back up.
That was a mistake. I was trying to unclick it and then clicked it accidentally.
It's all good. Okay, cool. So let me run this one more time. And then now we see it's the same thing, right? Because basically what happens if you have it this way is that animal, it's basically saying like, give me this animal value if this returns true. And if it doesn't, then what's returned here is a nil. So the nil is falsy, and so then it like works correctly that way, but it's not actually using find all like the way that it should be used. Yeah, cool. So I saw Arike, did you put your hand up? Did you want to walk through one, or did you want to talk about this one?
I wanted to walk through one.
Okay, cool. Which one?
The hash.
Cool.
So I did do a dot each for this one, but first, I guess on line 12, if you could write results equals empty hash. And then I put animals dot each do. And then in pipes, I put animal. And then I kind of spaced it out, like so end. And then inside, I put result, square bracket, animal, equal, and then I put animal dot length.
Awesome. Cool. And I'm just going to P the result so that we can see it. Okay. Cool. And yeah, that gives us a hash with the symbol as the key, pointing to the length of that symbol as the value. So yeah, defend why this is the best enumerable for the job.
Defend seems like a strong word. I think as far as simplicity and readability, it's very clear that, well, maybe where the hash is located might not be the best place, but yeah, right there would be fine. You know exactly what's going into that hash just by reading it.
Yeah, I like it. And that's like, I'm glad you kind of like brought up the idea of like defend being a strong word. I think it is a strong word, and it's kind of like, if you can, like we always say, or I guess maybe not always, but there's a lot of opinions in programming, but you're going to have to defend your implementation probably in group projects, on the job, to managers, to peers at all times. So I think it's good practice to always kind of like get in a habit of having, some reason. And which one you went with is readability. It's very clear to what's happening here, and I would agree, right? Like for readability, like this makes perfect sense to me. I have a hash as my accumulator outside of the each block, and I don't care about the return value of my enumerable. Like I don't care about the return value of the each. I'm using the each to populate the result hash. So yeah, I think that works. And yeah, I think that's all I'm going to say about that one. Thanks. Anyone want to walk me through, this next one? Go ahead, Angela.
I actually have a question about this one that
Totally.
we're working on.
Cool.
I used reduce.
Yep.
But I got an error that I haven't gotten before.
What's your error?
So I went animals dot reduce, and then in parentheses I put in the curly brackets.
Okay, yeah.
Yeah. And then I went result, comma animal as my block variable, and printed the that block, like the return value of that block.
Cool, yeah, let's run this and see what we get. Huh. No method error for 3 integers. Is this the same that you got?
No.
Different one, huh?
The curly bracket is not a symbol nor a string. Type error.
So, and does yours look exactly like mine?
Yeah. Oh no, I have a reduce at the end. Before the end. The block end. Not a reduce, a result. Sorry.
So you have this.
Yes.
Yeah, okay, cool. Yeah, this is what I was hoping we would have. And so if I get an error here, I'll be surprised. So
you're printing result.
Oh, yeah, okay. I need to P the return value of this. Cool.
There.
Undefined method, curly bracket is not a symbol nor a string, and that looks like it happens on 17. So yeah, let's think about this. Is there anything that I'm missing from this implementation? Can anybody look at this and say, oh, I can see what's wrong?
Can you do the length of a symbol? Anything?
That's a good question. And the answer is yes, because our other one worked up here where we had symbols, right? But yeah, good thought. Let's see if we can change this to hash.new.
I used a hash dot and a dot collect as well. Not within a dot reduce. Never mind. My apologies.
That's okay. So I'm not totally sure why this isn't working, to be honest. But I imagine that it has something to do with the hash. If I'm looking at this error right, I think it's like not liking this part because it says it's on 17 and
I
yeah.
did mine exactly like that, and it's working. The only difference is I set it equal to a variable and then puts the variable instead.
Okay, so you did, we'll just call this final, and then you did a p of final like this.
Yeah.
Let's see. Interesting. So this is quirky. I don't know what is going on there, except that maybe you can't use reduce this way unless you're saving it, which doesn't make sense. Let me try it a different way. Huh. Okay. Yeah, let's come back to this. We'll parking lot this and we'll go down this rabbit hole at a different time, but it looks like reduce is like okay if you're saving it to a variable or using it as the return value of a method, but not okay when you are attempting to like look at it, attempting to like look at the value, the return value without saving it to a local variable or using it as the return value of a method is what I'm gathering. So interesting. But yeah, this is why we do it, to figure things out, right? Like I don't know exactly what's going on, but I can see that it works one way and doesn't work another. So sometimes it's just best to go with the way that works. And I'll try and look into this more though, and give you like some kind of explanation after class. Okay, let's do this final one. Return an array of animals as strings. Anybody want to guide me on this one?
I can take it.
Cool.
This is Dan.
Hey Dan, go ahead.
All right, so I just did animals.map, do animal and pipes, and then go ahead and end that. I guess, yeah, end that. And then it's just animal.to_s for toString. And that worked.
Cool. Interesting.
Mine, animals map, do.
It's interesting because I'm like putting out the return value of this, but if I do it as a local variable, like strings, I think I will get something different.
Yeah, I put my puts with the animal dot to
Yeah. Because it looks like, yeah, let's just run this. So it returned, if I'm like doing it this way, it's telling me like what the return value I think of this is what it looks like to me. It's not like giving me the return value of the block, because the return value of animals.map would be, would be an enumerator. So I think it's just missing this. I think this white space like causes it to miss that, and then this block just gets missed when I do it this way. But if I, save the return value like this, then it looks like it picks up the whole block, and I actually get this ended return value. That's my theory so far. So Dan, why is map the best here?
I use map because we are basically having to modify all the items. We want the original number of items to be returned. And you don't have to use an accumulator like you do with each. So that's why I chose map.
Cool, I like it. Yeah, I think the two things I want to hit on is like, I need to do something to every single item in the collection, right? So at that point, that makes me think I'm gonna call that on every one. I want an array of the same length back. So that to me like feels like a map, and I don't have to set up like an outside value, right, of an accumulator. I can just use the return value of my map. Yeah, Philip, what's up?
In this situation, why wouldn't strings be considered an accumulator when you've set it before the block? Because doesn't that set this variable up that is empty until the block runs?
So let me repeat the question. So why wouldn't strings be the accumulator in this case? Because it's supposed to set the variable before the block runs. That's what you said, right?
Like just in my mind, I would consider that to be an accumulator. It's just you have it on the same line.
Gotcha. Yeah, so when we say accumulator, we mean like some value outside of like the actual iteration. So right here with strings, I'm saving the return value of this entire map do end block. That's what I'm saving. Whereas if I wanted to do this with an accumulator, I would do something like this. Now I've set this value as a certain data type that I'm going to use within my array, or within, I should say, within my block. And then, yeah, then if I do it this way, now I'm using an accumulator because I've set up an outside value. And now you could argue that map is not the best enumerable because map has a specific return value that we generally care about. So if you're going to do it this way with an accumulator, so like a data type that you're populating within the block, then we would want to do an each here, because if we're using an accumulator, in general, each is going to be our best choice. Does that make more sense, Philip?
Yeah, so it has to do with the fact that you're using map, because it just by nature of using map, you're creating an array. But if you're going to use each, that array has to be in existence somehow.
Totally. Yeah. No, you nailed it. That is the key difference there.
I have a follow-up question on that line of thinking, Tim.
Cool.
I did strings equals animals dot each do animal. I mean, it's the same thing that Dan did, except I use each instead of map.
So you did this?
Yes.
And then not this?
Yeah, that was it. It was exactly like Dan's, except I used each instead of map.
Gotcha. So if I run this, the big difference is I still have symbols here returned in my array, because what I'm actually peeing to the screen here is the strings local variable, and this local variable is the return value of this whole each block, and the return value of each is always the original array.
I see, but then I just did this in a pry session, but it did return converted to strings. That's odd to me.
That is odd. I think maybe you might have done it a different way. How about this? Let's have you screen share, and if you still have the prize session that you can visit, can you still see it?
Yeah, sure.
All right, cool. Let's get me off.
So there's where I started. Oh, nope, I did write it differently. I'm sorry.
That's okay.
I'm silly.
No, that's all right. That's why we look, right? Cool. All right. Good. See, this is why we warm up with something like iteration, because there's always like little details that until we actually understand these like little details, we're probably going to get mixed results and some behavior that we don't expect. All right. So coding is uh, in its essence, it really is very detail oriented, because the slight nuance changes that we make like really affect the way that the code runs. Yeah, let's take a break, come back at 1:30, and we'll jump into the exercise. I think this is a good example of like sometimes how things are being interpreted by Ruby under the hood. Like it's a syntax thing more than it is like some misconception of how things are actually working. It's like, no, like the syntax here, like Ruby's trying to like parse in a way that it doesn't like the way that you wrote this syntax, but put parentheses around the whole thing, and then it understands that like this operation runs first, then this operation. So for what that's worth, like I'll say like sometimes it's more how do I say this? Sometimes it's not even worth your time to like go figure out the why. Like not always, but I'll say like there's been times on the job where I've been like, this works. The screen and the commands are like doing like exactly what I expect, and then there's this other way that like doesn't quite work, so I'm gonna go with the way that works. This isn't ever always right. Like generally, you should understand the why of what you're doing, but like sometimes like it's not even, I don't know, it doesn't feel like it's worth a ton of my time to like go down like like the nuances of p and puts rabbit hole with reduce, you know what I mean? That's just, yeah, that's my opinion. Cool. Yeah, okay, so I'm going to what am I going to do? I dropped that repo in the channel, and I kind of want to just give y'all some time to explore it. So I'm going to put y'all in some breakout rooms. And what I want you to do is like, you don't necessarily have to like do driver navigator. If you want to, great, go ahead and do it. If you don't want to, like, that's okay. You can start exploring on your own. But what you really should plan on doing is running the test suite. And what I want you to get practice on here is like using the test suite to be your documentation of what's going on with this repo that you're unfamiliar with, right? Like sometimes we say testing provides documentation for developers to like get up to speed quicker. And so that's what this should do. So if you go to the repo, there's a README. It's like, hey, like check out the school or the student test and run it. Check out the course test and run it. And then from that point on, there's some skip tests in course where you need to like implement some functionality. So here's what we'll do. We will have you spend like 10 minutes, and I want you to get familiar with the repo by running the tests, and then I want you to see if you can implement either of the course. I want to see if you can implement the methods that exist on course or implement methods on course that are being tested in course test, and see if you can get through any of those. And we'll come back together and do it as a group after that. Any questions on what I'm asking you to do? Cool. All right, I'm gonna open the room. See you soon. All right, looks like we have everyone back. So who wants to maybe just like walk me through this repo? Like what objects are there? Which objects hold other objects? What data types are used to hold other objects at this point? These are the things I want to know about this repo.
Where do you want us to start? Courses, school.
I want you to start where it makes sense for you, and I'd love for you to like show the code and explain like what it represents.
Okay. Did I just volunteer myself with that question?
Wait, say it again.
Did I just volunteer myself with that question?
You sure did, Danny.
Super. Okay. Thanks, guys, for your patience while I figure this out. Okay. Okay, well, I guess we'll kind of follow along with what the README is saying, I guess. So we'll start with like course test.
That works for me.
Okay. So to me, it looks like with our setup here, we have a course has a course is it's a course object in and of itself that houses students. So to me, it looks like that there's a course that has like class types maybe in the form of a string, and then it's going to add students, the student objects into whatever. In this case, it looks like we just have one course. So I'd say that the courses hold the student objects. Is that accurate so far?
So far, so good. Yeah, I love it. Here's what I will ask for you to do. Is there a way that you can, do you mind showing the course, like whichever test you're going to show on the right, show the class file on the left?
Yeah.
Cool.
Can you see that? Okay.
Totally.
Okay. So it looks like based on our like tests and stuff like that, that we are wanting to add students to the course that we have, this potions and service snap. Sorry guys, I'm really not a big Hogwarts person, so if I mispronounce those things, please forgive me. So we're adding students to those courses, and then we are wanting to find out which houses are represented by the students. So the students hold the house objects, I believe. Is this true?
So so they have a house. Each of them have a house adder accessor, and those houses are represented by symbol objects.
Right.
Yep.
Cool.
Cool.
So that's, I think, where we are right now, I guess.
Cool.
So the course holds the student objects, and the students have houses in the form of symbols.
You got it.
So I can close these now?
Well, I was hoping maybe you could walk me through your implementation of houses represented.
Okay. So we know that since the houses are associated with the student, we decided to map, because we know we want to kind of return an array that has some of the original objects, but meet a certain criteria. And so we know that we want to get an array of the students based on which house they're associated with, and then call the dot unique at the end so that we wouldn't replicate multiple houses. We just want like the single house, each single house kind of represented.
Cool, I like it. What I would say about map is the reason we want to use map is because we're transforming from one type of object to another type of object. So in this case, we start with student objects, but the type of object we want returned in the array is a symbol, right? And we can tell that just from the way the test is set up. Yep, exactly, on 41. And what I'd love for you to do here is pry in, how can we do this? So pry into house is represented and run the code.
Okay. Do you want me to go above or below?
Above the map.
Okay.
Yep.
Let's get out of this prime. Hopefully I don't have it still in there. So we want to test in the course.
Cool.
Okay.
Cool. Can you run everything? Can you see what at students is? Okay.
And student objects.
Yep, exactly. Looks like, yep, and I can see that, and I can see that there's houses of Gryffindor looks like duplicated. So can we run everything but dot unique?
Yeah.
Awesome. So this is the thing to note about map, always going to return an array of the same length of whatever you started on. So here we have the Slytherin, Gryffindor, Gryffindor. So we're getting the house attribute from each student object and getting that returned in an array. And then based on the test, right, that's why Danny added the unique, because she wants only unique elements of this array, so only unique houses in this case, which are represented by symbols. So yeah, thank you for sharing that. Any questions about this implementation?
I have a question, Tim. It's not really related to the implementation, but so in Danny's pry session, you can see the student instances are basically, it's like the Ruby ID. Is
Yep.
there a gem or a way to like have that be represented as student 1, student 2, like for readability? Sometimes I struggle with like kind of just deciphering that, especially when there's more or it's like, you know, in a time challenge. Is there anything that you've seen that would maybe improve readability in the terminal?
Not that I've seen, but if you went to Sal's How to Make a Ruby Gem class, then you've got to start for making your own gem that does exactly this.
I'll let you know when I create it.
Okay, perfect. I would love to use it in lessons once you're done with it.
I'll be rich.
All right, cool. Cool. All right, yeah, thanks, Danny. I think I don't need to show you that again because we walked through it with Danny's. So let's take 5, and we'll come back and go back to breakout rooms, and I want you to like start working on the school tests. So we're back at 55.
55.
All right, it's 55, so let's jump back into it. This time, I want you to start working on the school test, and so the asks are a little bit bigger in the school test as far as like what we want you to do. What I don't want, let me just share real quick. I don't want you to go past this method. All right, so don't do list all students by house just yet. I want you to work on these first two here. Test it can sort all students, and test it can list all students by name. All right, those two. If you find a way to implement it, I want you to practice implementing it with a different enumerable than you used. All right, so that instead of like moving on and trying to like finish the repo, it's like, no, like let's slow it down and try and implement this with a different enum. All right, and then we'll take like probably I think we'll take a while on this. We'll take like 20 on this. And so like if you come up with like a cool way to do it, great, show your partner, try to come up with another way to do it. Yeah, I'm gonna jump into some breakout rooms also to see what's going on. And then yeah, we'll come back together and I'll show you my process for this and then we'll share some solutions. Cool. We'll come back together at 2:16. All right. Good to have you back. I went like a couple minutes longer just because there was some solid struggle going on that I didn't really want to break up. But I think just based on where the groups were that I like watched, I'm gonna kind of run through it. And I think the thing to focus on here that uh, I I saw some groups like missing pieces is just like process, right? Like, what does my process look like for solving this problem? So let's focus on that. And if at any point, if I like skip over something, or if you're like not sure why I did something, feel free to go ahead and unmute and interrupt and say, hey, like, why'd you do that? So cool. So I've got this school test, and one of the things I wanted y'all to do was like try to focus in on how these objects are set up, what objects are holding what, and which objects have access to other things. So we've got this. The one thing that's really easy to skip over here is like, what is school initialized with, right? So it's got a name, it's got an array of possible houses, right, that are just passed in as the argument here. So this like just kind of looks like it's a hard-coded array. And then also I'm initializing this courses array to be empty. And then I see my add course with a course. I've seen this pattern quite a bit by now. So it looks like I add courses to the courses array. And then this one looks a little different than what I'm used to. Looks like we've defined a sort method, and that takes a student argument, and then whatever student I pass in, I call the dot house method, which makes me think immediately like, okay, that's probably a student object, because if I look over at student, I can see there is a house and it's initialized to nil, and it's an adder accessor. So that gives the school the ability to not just read this value, but assign it here. And so it looks like it'll be assigned to one of these 4 houses that I pass in. All right. And so if I didn't take the 45 seconds to a minute to like figure all that out, once I get into the weeds of the code in school, it's probably going to be a little bit more difficult than it would be if I took some time to like really understand the why of what is set up right now. What do I have right now? And another way that I can figure that out is I can look at the attributes. Okay, that makes sense. We've kind of gone through that. Then I can see this add course method. All right, that is exactly what I expect. But here is where the pattern sort of shifts a little bit, and it's kind of similar to add course in that this is a command method, right? And then this assertion isn't exactly what I've seen a lot. It's basically saying like, hey, on our school object, if I look at our houses array, does it include the student one dot house, and that student is the same student I passed to course here. All right. And so this is like where I kind of need to also like kind of hone in and say, okay, let's see what's going on here. And I think I understand what's going on. Like I pass in a student object to the school, and then it gets assigned a random house based on the implementation here on line 15. So any questions about any of this? Like my approach to just looking at what's going on, what the functionality is that's already existing in the school, really in all the objects.
No, I think where I got confused was looking at the interaction pattern, which that tends to be a common thing for me for whatever reason. Because I see that it calls the school.sort student one, and then you have like student one.house would be like your assertion.
Yep.
Then where does like the student one.house, student two.house, student three.house, where does that all come into play? I don't see it in the test anywhere. So I was like, do you add that? Are we supposed to add that in, or?
I see what you're saying. So like, yeah, here in this interaction pattern, we expect, so we expect this to be like one of those 4 houses, right? Like one of those 4 houses that could possibly be assigned in the school object after this runs, right? So this is our command method, and this needs to make sure that when we run it, all of our student objects basically have a house is the idea. And that's kind of like what this is saying. So yeah, this, I mean, I'll go with you on this, like slightly confusing, slightly different than what we've seen before, but like kind of by design also to like make you have to like take an interaction pattern that's a little strange and like no more pattern matching on this part. It's like, you gotta like problem solve a little bit more. So totally get it. It's like, yeah, it's a little different. Any other comments or questions about this before I get started? All right, I'm gonna unskip this test. I'm gonna put it down here. And yeah, so I get 3 courses. I call this method sort students. I hard code an array of all of my student objects, right? Those are all defined up here, 1 through 7. And it looks like all of those were added to a course object in my setup method, so that I would assume at this point that if I have all 3 courses, I also have all 7 students. Everybody okay with that assumption? All right, cool. So let's go back down to this actual method I'm doing. Test it can sort all students. So let's run it. I can TDD my way through this if I run the right test. Okay. All right, so undefined method sort students, cool. If I'm TDDing, I don't have to think yet. I know how to get by that method. Cool, now I get a failure, so it looks like the code's running. Expected false to be truthy. School test 74. So if I look at 74, at some point, this ran for one of my student objects, and there was a false returned instead of a true. So now I have to think, right? I have work to do. And at this point, I want to probably pry in here and look around. All right, so I can tell I'm a school object, but I'll just look at myself. Okay, like there's a lot going on here. At this point, when I do that, I want to make my terminal window big so I can see as much as I possibly can. All right, I'm a school object, and I have at courses, and then courses also have students. And now I'm just like thinking like out loud here. If I like want to get on to, I know I need to iterate, right? So I know I need to get on to courses, and then from that point, I need to get on the students, because I can tell that all my students don't have a house right now, and the whole point of this method looks like to assign some random house. So I know I need to probably do that for all the students that exist on all the courses. So from this point, I'm going to say like, all right, I think I would start on at courses, right? Hopefully that's an array. And it gets like a little bit distracting, like Dan was pointing out. He's like, I get distracted by all these objects. I can always call .class just to ensure. And if I know I have an array here, then I know I can set up my first iteration, right? I can set up my first block at this point. So that's what I'm going to do. I'm going to say, all right, I know course is an array. So what I want to do is set up my each, so that I can get down one level deeper in here and put my pry in here and now look around. All right, and so this is like, you've seen me do this process before, but it matters because sometimes when things are so abstract, it's like, all right, like one thing at a time. And this is my process, one thing at a time. I know I want to get on my each. Okay, undefined method, so I screwed something up. Yep, I'm sure you've seen all this. Like, these are common mistakes, right? I called this course instead of courses. It's another reason why it's easier to copy and paste from pry. And let me just put this here. Cool. So now I hit the block. That's step one, right? Get the code to even hit this block. Now I can look at my course. Cool. I can see it has a name, professor, and students. Students is what I'm concerned with. So let's say course.students. Okay, that looks like it gets me closer to where I want to be. But if I look at the class, right, if it's an array and I want to do something to every one of these, I know I'm going to have to iterate again. All right. And so at this point, I'm thinking, okay, once I have course.students, that's an array, and I'm going to iterate one more time and set up an entirely new each block, right? I'm going to set up a new each block for my students and hope that at this point I have one student object. That's what I want. That's one step at a time, one pry at a time. So at this point, when I run it, looks like I can get in here, and I'll make this slightly bigger, sorry. Cool. So now I can see in here, and I'm like, all right, I'm within the block. Tell me that the student is a student object. Yes, it looks like it is. Let me just make sure. Awesome. All right. And now at this point, if I have a student object, I'm thinking based on the way that this test it can sort a student method runs, right? At school dot sort and then pass the student. That looks like that runs just fine. So I'm going to say that at this point, when I know I have just a student object within this block, I can run this for every single student. And that's what I'm going to try and do. So I'm going to say sort student, and this is only going to run for one student, right? But if it's within my iteration, then I know that it will eventually run for all students. Cool, I get a return value of Hufflepuff. Now when I check out my student object, whereas before the house was nil, now the house is Hufflepuff, right? So that works for one. So I'm going to say, you know what? Let's try it out for all. And what I'm going to do is copy and paste, because if it worked in pry at this point, I know it should be able to work in the code. So I'm going to call that there. I'm going to exit out of this. And if I run this test again, this time I have assertion. So that means that every single time this assert ran for all 7 of these students in my test, indeed, there was whatever student.house was assigned to a student. Yes, that was included in my houses array. All right, yeah, I saw some hands go up. Let's see who was first. I don't know. Okay, Adika, you're first.
So I was curious as to, like, we're iterating through, but if you look at the courses, there's a repeat of students. Like if you look on pry, courses has like 2 Harrys, and I think it has 2 Lunas in different courses. So I was wondering if that was a sign enough that we should put up a guard so that we don't reassign students.
Yeah. Yeah, so you're saying at this point, I know that courses, let me make this bigger. I know that courses is an array, and I know that some of these students are in there twice, right? Like Harry's in there twice. Who else is in here twice? I think Luna. Yeah, Luna's in there twice. So you're saying like, hey, I don't think we should reassign this. I know Luna's going to get assigned twice, right? And I don't think we should do that because that's duplication. And here's what I'll say to that is, yes, for sure, that is a detail I want you to find. However, based on this test, nothing in this test says I can't reassign it. Performance-wise, it's not great because I'm doing something twice that I only actually care about doing once, right? So what I could do, right, is I could set up a method that is called unique students, right? Now I don't have a helper method So, or I don't have a test. So let's make a test first, actually. Let's just TDD this. So if I want unique students, and I know I want the exact same setup as I have for my sort students method, and then I say I want at school, or I need an assert equal, and I probably want all of these unique students, right? I know that these are unique, so I'll just use my expected value here. Assert equal students, comma, at school dot unique students, right? And at this point, yeah, I think I'll just skip this one just so we can focus in. So at this point, I'll start my TDD process. Yeah, let's go here. No, sorry. Okay, so I've got my unique students here. I think that I should get an array of these students when I call this method. Oh, man. Did I not define it? Oh, this is...
Yeah, you put it,
Called it
you
a-
didn't put depth test.
You're so right.
Can.
Cool.
I hate to see it.
Yeah, I hate to see me forget that. Thank you for noticing. All right, so undefined method unique students for my school object. Cool. So I know how to figure that out. Unique students. Great. Now I get my failure, right? I want all of these specifically unique student objects, but right now I have a nil. So at this point I have to do some work. And at this point, I'll pry in, same as before. Remember, the process isn't changing much here besides me forgetting to name my test method correctly and getting some help. But other than that, the process is pretty similar. So let's make this big so you can see. I have at courses, and I want students, right? So let's do one thing at a time. So let's go courses, and I want to turn it into students. So I'm doing a map in my pry session, so I don't really want to do that. I want to know that I'm going to iterate, and so I'll say courses dot map. I know I want students back, so I'm going to just try something. I'm going to try a map, and I want to say course. Actually, I want to pry in, just because it's one step at a time, right? All right, so now I'm here, course, cool, course dot students. Cool, I'm close. I don't really feel like having to do a flatten. So what I'm gonna do is change this to a flat map, and I'm going to say course dot students, and just see if that gets me what I want. I don't think I'm done yet, but I can always run the test and see what the outputs are, right? Cool. At this point, it looks to me like I'm closer, right? I can see that like this array here, the actual array looks bigger than my current array. So I'm like, all right, I think what I can do here is look and see if those duplicates are still in it. Yeah, indeed, Luna's here twice. So at this point, I need unique student objects. So I'm gonna see if I can just call a dot unique here on this on the end of my flat map, and I hope this works. I really think it should work, and it does. All right, so at this point, what I've done is I've said I'm gonna make a helper method called unique students, and then you know what I'm gonna do? Instead of having this sort students method here, I'm gonna start with unique students, and then I'm going to sort each of those unique students. And so here's the big shift that I'm gonna make, or the big jump, is I'm gonna redo this method. And the only thing I'm going to do here is I'm gonna start with my unique students. I'm gonna each over them. I'm gonna do student. And I'm gonna sort each one. All right, so now I feel like I've got a unique student. It's only gonna happen once. I'm gonna assign this value. I know I need to unskip this test now. see if it runs properly. If I run it, cool, it still works the way that I expect. I saw a hand go up. Angela, what's up?
So given what you just did, are nested iterations like a good indication of something that needs to be refactored?
Sometimes yes. So what I'll say about nested iteration is avoid it if you can. Sometimes it is unavoidable. Sometimes whatever you're doing in that nested iteration block, you need access to both the outer block and the inner block sometimes, right? So a good example would be like, I have keys that are symbols. I have a hash, and I have a key that is a symbol, and then I have value that is an array. So I know if I want to each over each key value pair, but then also each over each element of the value of the array, then I need a nested iteration set up, right? I need to be eaching over the outer hash and then the inner value of each key value pair, which is an array, and say like within that, I'm using my outer key to do something to my inner array value. And like at that point, I need both because I need something from the outer block. Nested iteration is unavoidable at that point. You need both. So you have to do it. If, for example, yeah, this is one where I went from a nested iteration here to a not nested iteration helper method that then I start on and then do only one time in the block, right? So in this case, I started with a nested iteration, realized thanks to Arike like pointing it out, like, hey, we've got some duplication. And then I was like, ooh, yeah, I don't want that. So I went and took out both the duplication and the nesting, put it into a helper method, and now I just start there and I do it for each student.
So, and more with clarity than it does with performance, because you're still iterating, doing the same amount of iteration. It's just more clear if you separate it.
Not true.
No? Okay.
Yeah, so I'll try, I think I can show you an example of how it's not true. And I think that the better example is the next one, so I'll show you there. But like, yeah, the number of times you actually iterate performance-wise will always be more of a performance hit, so not good performance if you're doing nested iteration, because it's like a exponentially more expensive command.
So this helped performance by breaking it up.
Correct.
Okay, cool.
Yep. Cool. Danny, what's up?
When would we, I guess this is kind of new to me, like in your test, it can sort all students. You're using an enumerable for that assertion as well.
Yep.
Can you just talk about that for a second? Like,
totally. So one thing I would rather do to make this a better test is not use assert. I've told this to a couple of you. So I would rather see an assert equal true and then this here, because that's just a better test pattern. But there are going to be some times where you need to set up iteration in your test. And in this case, we kind of have some randomness at play, right, for each of these. So this include method is a way for us to kind of still be able to test the randomness that is possible for every student object, right? Like we still want to make sure that from within our school object, one of these houses is existing on our student object. So this is like a pattern that we can use to achieve that, right? Like this is like a way that we can achieve through iteration in our test. Like tell me that this tell me that this condition that I have in my object, my at school object, which is I want to make sure one of these houses is on each student, is true. And we can do that with the include operator, because that's exactly what include's built for. It's like, hey, look at this array. tell me if this return value, this symbol, is included in this array. If it is, you get a true. And this is a way, so now I can say, like, did this actually run for every student, because, like, properly? Because for it to have run properly, they all should have gotten a house, not just any house, but a house that exists from my houses array here that was passed in when this sample was called. And that's the randomness that this is now a way, include is a way for me to test this randomness.
And you're starting the students.each_student just so that you're making sure that it goes through each one of those students in that student array above.
Yeah, exactly. I want to make sure that for every student object I created, like, all of them got a house that exists on my school object. And that's what this, like, kind of loop, or this each block, is really doing. It's like I'm testing the exact same thing for every single student object. Yeah, just so you know that I wasn't lying, that actually works. And then this is just a better test, right? Because it's first, I mean, to me, it's more clear. If you know about include, you know that assert will work just fine here, because include will only ever return a true or a false. So, like, I just think this is a better pattern and like a better way to test. Okay, so let's do, yeah, we're running out of time, but I want to go through this one. So test it can list all students by name. Cool. So and we're going to assume that I didn't build unique students here for some of this, for at least the beginning, because it's better to go through it that way. Cool. So let's run this test. Great, undefined method student names for a school object. I can get rid of that error by doing this. Student names. I can't spell. Student names. All right, see if that will run now. Great. Now I get this list of what looks like unique student names, right? Like compared to my nil value. So now I have to do some building. So I'm going to pry in, because this is a new test method, new everything. I want to make sure that courses looks the way I expect. Okay, cool. Courses has my students, and yeah, they looks like there's still some duplication here, right? If I'm looking at that correctly. So I'm going to try and avoid the duplication right here in the block. So I know I'm going to start on courses. I'm going to each over it. I'm going to do a course and end. All right, so similar process. And now I'm going to say pry, and I'm going to look in here. Oop. Okay, now I can look at course. Cool, this is an individual course object, and it has students. But I still know at some point there's going to be some duplication if I don't create some kind of condition for it. So I'm going to say, all right, I know I need to get on to students here. Course.students.each do student. I know I can always start with each, right? Because each is always going to be my friend. I just need to, like, make sure that I'm setting things up properly. Each is always like something I can start with, and I can change to a different enumerable at any point that I feel the need to. All right, but now I have student objects, and I know I need a name based on the way that my test is set up, right? So I know that over here, the expected value is an array of names, okay? So cool, and also let's just make sure I can get student.name, awesome. All right, so one step at a time, right? So I'm using each, so I wanna set up an outside accumulator here now. Student names, make it an array, student names, and I wanna shovel in student.name. That feels good to me. Ah, terrible. Okay, so what happened here? This is a common thing you'll see, right? You're like, I thought I just set up this pattern right, and now this, like, actual value is so ugly. Anyone know what's going on here? Why is my return value so different than what I thought was going to happen here? Go ahead, Priya.
We haven't, so because it's dot each, it's going to keep trying to return the original. And so student names hasn't been recalled. So we haven't actually called that array. And we might even want to add in a dot unique to avoid any repeated names.
I love it. But here's what I'll say about that is I'm not going to get ahead of myself just yet. I'm going to do one thing at a time, and I'm going to explicitly return student names. So I like where your head's at. Now I can read this a lot better. This feels a lot less scary to me as far as like my actual versus my expected. And now I'm looking and I'm saying, oh, I see that first duplication with Harry. I see it over here with Luna. Cool. So now at this point, I want to go with unique. Great. So I want to show this both ways. So let's do a count. Let's set it equal to 0. And let's do a count plus equals 0 or plus equal 1 every time I go through the block. All right, so this will show me what nested iteration costs, like how many times I actually iterate for this. And I'll p count. Actually, maybe I'll just, yeah, let's see. Cool. All right, so this says 9. Oh, I got a failure. Oh yeah, because I did this wrong. Cool, so it's 9 every time. I get it right here. P to the screen, not the most clear thing, but it's 9. Now, let's say I avoid nested iteration. So let's do something like this. Let's do, I want to see how I can show you all this in the most clear way. All right, so I'm going to avoid nested iteration. So what I'm going to do is comment everything out so it's still within seeing. And this time I'm going to say unique students dot map and do a student and student dot name. Yeah, so let's go in here and this isn't the best example. Sorry, I want to reset. I want to set it up a little differently. Let's not use my helper method. All right, so I want to just start with courses, and I want to get back students. So let's flat map do course, and let's do course dot student. Cool, and I'll set up my count variable. Count is 0. Every time through, we'll do count plus equal 1. Cool, that looks good. And I know I'm gonna need this. So this will be students. And then I'm gonna say students dot unique dot map do student and give me their names. Student dot name. I've got an eerie feeling that I need to save this. Names. I've got an eerie feeling that this is not going to show my example, so I'm just going to put that out there. But we'll p count and then we'll return names. All right, so this is kind of like breaking up that nested iteration, right? Where this is like clearly nested iteration, and this is clearly like, nope, we start with courses and we go to students, and then we map over students and we give them a name, right? So Let's run it. Bad. Undefined method student for course. Okay, so that needs to be students. 10. So here, my example worked against me, and we iterated more this time. Let me come up with a different example, and also say that just trust me, in general, nested iteration is more expensive. Trust me, nested iteration is more expensive in general. However, I'll come up with an example here that shows it better than the way that I didn't show it to you here. All right, since y'all have PD, I don't want this session to run over. I can give y'all, if you need to go and like take your break and everything and be back for PD at 3, that's fine. But I'm also down to like do questions until 3-ish.
Does that mean the PD is here and not the separate link in the calendar?
No, so the PD is in the separate link. So I'll,
Okay.
I'll say I'll take questions to like 2:58 if you have them.
Thank you, Tim. Have a good
Of course.
day.
Yeah, for sure.
Since we're talking about like performance, what is more expensive, like memory or like iteration, if that makes sense?
Say that one more time. Sorry.
I wanted to know what is more expensive in terms of like how my a program would run, whether it's memory, like storing things in memory, or doing multiple iterations while not storing things in memory.
Yep. Depends on the size of your collection. So depends on how many actual like elements you have to iterate on, number one. And then also depends on how much memory like your server has at that time. So that's also kind of like both things are pretty variable. So it's just like a trade-off. You kind of have to know some other things about first. It's like, oh, like I know I have a small collection, so I know that I can allocate like variables kind of sparing or not sparingly, loosely, and not worry about like a ton of memory being used because my collection's small. And so if I like assign a variable each time through, it's not going to be a big deal. But that being said, you kind of have to know, man, it's even like language specific how much like memory storing variables takes. I will say that like mostly like in general, you're not going to like run into a problem like where performance is affected as much by how much memory you're using to like store things. In general, you will run into performance issues because of how large the collection is that you're iterating on, like much more often than because you're like storing something in memory. It's like that is generally like a system level, server level problem that you probably won't be working on. And you like the best thing about that problem is like generally like software languages are taking care of that problem for you and like thinking about that problem up front, whereas how many rows you have in your database is totally up to you and totally up to like the number of like users that are using your app. And so at that point you've actually got to like you're going to run into that problem far quicker than you're going to run into the memory problem.
So for a project right now, we have like at least one of our collections is like 15,000 lines.
Yep.
Are we better off storing, like say if we needed to do like the same iterations for different calculations, are we better off storing some of those results as opposed to just creating methods that we call inside other methods?
Yeah, so you want to avoid doing the expensive operations like more than once. And so what I'll say about that is like, yes, I totally like, so avoiding nested iteration where possible is one of the ways that you can increase performance. The other one that I'll tell you about is memoization. And memoization is basically like, I think I talked about it possibly with a project group, but it's like the idea of like, hey, if this value exists, go ahead and use it. So it's like if this value is not nil, use it. If not, perform expensive calculation on the right of the memoization operator. And that's a way for you to, like, if you're like doing like expensive math, it's like, hey, only do that expensive math once, and then like use the value that you did the expensive math on every time this method is called down the road.
Okay.
Yeah. All right, I'm gonna let y'all go. See ya.
Hey, Tim, do
Hey,
you have time for one more question?
nope, you gotta go to PD.
Oh, man.
Sorry.
All right, see ya.
See ya.